Here from Laserscanning Europe, Laserscanning TV, and this is my walk around on the 2025 Intergeo, and we go to different vendors what we find interesting. But one point what we definitely see this year is a lot of mobile scanning. I think you can see we have mobile scanning system on the right side. We have like a mobile mapping car here. There's many more, and handheld scanner, GPS. Let us go. Hello, we are here on the booth from AISPECO, and I have a nice gentleman. He maybe introduced himself and talking about where your company coming from and what is your main things what you're doing.
Hi. Yeah, so we are AISPECO. I'm Simon. I work for AISPECO almost from the beginning. I work for business development. We are a company, geospatial company. We provide tools for data collection for mainly helicopters and planes. We have right now one of our newest products, which is a light platform for planes, like Cessna 182, 172, 206. Also some helicopters as well, like MD500. It can be mounted on Bell, can be mounted on AS350, for example. What's good about it is that we have the availability, we as the integrators, to put different types of sensors. So different LiDARs, Regal, Teledyne, we have now also CHCNAV, and cameras, for example, Phase 1, Fuji, Sony, hyperspectral imaging, infratech, let's say thermal cameras. This here, also if you can come a bit closer, so this is our custom stabilizer. This is a 2-axis stabilizer that works individually, both for cameras, so for the roll and for the heading, also for the LiDAR, for the roll, which increases the efficiency of roughly 10%. This can be mounted very easily. You can see here mounting from Meeker Aviation. So this is STC compliant. You come with the Pelican case, you mount this easily. If, let's say, you work in different places, you don't have to mobilize your aircraft. You can rent, for example, Cessna, which is the cheapest entry-level method to get the survey-grade data.
So one question what I have is how you get the energy. Also, did you have your own battery, or you can have a plug-in and you can use the power from the airplane? How is this working?
Yes, so also various methods. We ourselves, we used to be surveyors, so we know some of the struggles that our customers have. So there are various modes how to operate the system. So firstly, like you mentioned, you can use the aircraft power. Secondly, we can have a battery, which is also portable. So it's relatively easy to connect. Inside the cabin, it goes size like this, sensor controller, plus the battery pack. Easy to take with you. You don't have to drill any holes. You don't have to do any modifications. It's very compatible system that I can take myself in the airport and fly, avoid any customs, any things like that, fly very easily.
We also deliver like the flight control software.
Yeah, so we have a full solution. So not only the hardware, but also the flight management system. So it is, what's good about it is that it's fully integrated, so you get full control of the sensors. We as an integrators, we provide real-time previews, we provide all the information from each sensor. Everything goes into one SSD slot. So all the information from camera, from the LiDAR, from hyperspectral, whatever, goes into one SSD slot. For example, during the flight, if something happens with the sensor, you can troubleshoot it. You can restart it. I did it myself in some of the operations without landing. So we do the loop, we repeat the segment, and we are good to go.
Ah, okay, cool. Let's see here. You can see in the mirror. We can see. I think here we have. There should be the opening for the camera. Oh, this one.
This is the camera. This is, of course, a dummy camera.
Yeah, and this is the laser inside. And the laser is for the operation. You moved in the laser, so.
So this is active stabilization. It is also, everything is upgradable. So for example, what you get is the pod. Let's say right now you have one camera.
Okay.
Business is good, you want to upgrade it. The same pod, same components.
Okay, you can change it.
You add it. So it's 4 attachment points here and there. Unscrew the bolts, slide this out, add the sensor according to your application, put it back in, and you are good to go.
This is a magnesium or aluminium?
So this is aviation grade aluminum.
Okay.
This is SLS casing. What's also important that here we have fiber optics media converter.
Okay.
So all of the cables, Ethernet, USB, GG, whatever, goes here, converts to fiber optics. This allows you to have very thin cable and long cable, which does not interfere with any mechanics, electronics of the aircraft.
Where you have the GPS system, you have it then on the airplane, or do you have it inside here? Or?
So the positioning is, we usually work firstly with the Planix, but also we are available with Novatel, with SBG or other brands. The IMU would usually go on the LiDAR, and then the INS is inside the sensor controller.
Ah, okay, good. I think that was a deep implication in airborne data capturing, I would say. So, I'm here on the place from SCANTRA Software, a long-time partner from us, a company from Germany, but maybe Daniel introduced the company and himself.
Yes, hello, my name is Daniel. Basically, software we develop is called SCANTRA. It's a vendor-neutral software. That means we try to incorporate all different vendors, ideally, of course, with native formats. And if that's not possible, you can always use exchange formats like E57 and LAS. We're a geodetic company. That means that all the metrics that you learned during your survey classes, that you can basically find them in our software, like weights, error propagation, and such. And the other thing what we're famous for are that you're always able to process huge amounts of data. So, for instance, if you have 10,000 scans, you can use an ordinary computer and process that in our software. Or if you have a mixed fleet of scanners, you have 5 scanners in one project from different vendors, so different manufacturers, you can throw that in one adjustment, optimize it, or different sources, kinematic and static mixed, and then update everything. That's what we do.
I think maybe the interesting part is, maybe it's going a little quickie, so the one point is I would summarize your registration software for terrestrial and mobile scans.
Correct.
And you are vendor neutral. I think that's the key fact, and you can operate with large data sets.
Yes.
I think the biggest number what you have processed in one project was around how many?
13,000 static scans.
13,000 static scans. I know no other software on the market who can do that. And also maybe from the history, the basic technology or the mathematics behind them is very old for a tech company. Yeah. So how old is the company?
I think 1989, and the thing is,
it was a spin-off from a German university.
Yeah. So and the thing is, we also develop our own equation solvers, so that also helps to get it very fast and efficient. And I think we started implementing 20 years ago.
2011?
2004? No, that was commercialization, but the academic implementation started in 2004.
2004.
Yeah.
And the first product was 2011, 13?
Commercialization 11, I think 2011 it started.
So it's now, And we use the software also in our company, especially if you have large projects. I think it's definitely one software who deliver very good results for adjustment. So I would say it's if you have big data sets, I think it's the right tool from my point of view. So Daniel, maybe we can show something?
Yeah, sure.
Sure. So he can show you something, what is the typical problems what we faced if we use scanners and how they can solve it.
When people think of registration, they typically just think of concatenating different or single scans, static or kinematic together. The problem is that you always have error propagation. So what is unique in our solution is that we compute error propagation, that's one thing. And the second thing is, if you see here on the left side, this is a typical cloud-to-cloud or concatenation of different single scans. So you do pairwise registrations between scans. So you have 1 to 3, 1 to 2, and so on and so forth. And in the end, you eventually should have got a loop closure, but if it's not detected, you got this. And you essentially want to have this, and that's actually global optimization. And this is what we're basically known for.
This means, like, if you're looking on this, the accuracy between two puzzles, as two scans, is very good. But on the error propagation, finally they can have a big gap on the end.
There can be discrepancy,
so
yes.
That is the global, what you say, the global error, what you produce.
Yeah.
So, and I think that's, from my point of view, it's a very good one, that the fixing of this global problem, I think you have one of the best solution for that. So to make this to that one.
But also, that's not like this thing.
But also the piece-to-piece, piece. So it's both so. But I think that you have good solution for neighboring relation.
For adjacent.
I think that you have also in many vendor softwares.
Yes.
They can handle this very good. If you have 30 scans in one area like this, or 50 scans, you get it out. But if you have different layers, floors, rooms, and have this problematic, I think the best method to do this is with your software. So from my point of view.
The bottleneck is actually optimization of all of this. Because the problem is, other vendors, they use huge structures, and then the RAM consumption goes up, and then everything explodes eventually.
That's a point. How they make it is like they're not using the single points. They're working on patches, I would say, or like planes, patches.
Well, that's not the point. It's actually we have different stages. So the very first step is extraction. Then we use pairwise registration, and you could also use cloud-to-cloud. But what we then do is we optimize the network based on pairwise registrations.
Okay.
So that makes it even smaller.
So.
And then that allows us to go very big in a very short amount of time. That's the idea.
I think this was a deep dive in adjustment calculation. It's maybe what's new was last year, this year. Actual problem is that you are looking not only at terrestrial scans, you are also now strong focused on mobile scans.
Yeah.
So like SLAM scanners, mobile mapping system too.
That's on the agenda. That will take a while.
Okay. Yeah. Did you see that with mobile, where you see the challenge with mobile mapping, where you see what you see? I think in mobile mapping you have already GPS position, IMU position. It's this more the problem if you go one way and you come back, and then you have this overlap from two sides of the street. Is that what you're looking to fix? Or?
The problem is typically if you go, for instance, the typical problem is if you have a crossing. So you go one direction and then 3 or 4 hours later you come back, and then you have a different GPS constellation, or there's a truck next to your mobile mapping vehicle, and it shields off the GNSS signal, and then you've got this. So you get two roads, which is never a good look in the point cloud. So we're trying to fix that, getting out the contradictions. And of course, very important for our software is always the error documentation. Everything should be, if you need to go to court, we should get sound geodetic numbers to support it.
Your report is not only the green, yellow, the registration light, the traffic light stuff. You get a complete registration report.
Yeah.
But sometimes my engineer says, okay, for people that maybe have not the big survey background, it's hard to read what does it mean, because you say estimated accuracy should be this, and
this is
what you get is
that's
what you got. This is very good if it go to the GRID. So, but as for some easy users, maybe not the right choice.
Yeah, that's correct.
So, but I think if you have not good experience with adjustment calculation, you maybe should not take a project with 5,000 scans. So,
no, but actually, the interesting thing is the biggest group of new clients are actually craftsmen. So because they now use digitization, they scan construction sites, then they digitize it. They use a CNC machine to then produce it, and then they go back to the construction site, and then assemble it, and it has to fit. If not, they're wasting money. So of course they don't use error propagation and the geodetic stuff, but it has to fit. That's what's really important for them.
Okay. I have one question to this one. It's now we have a little bit development on the market that we have the high-end product, but now also new systems coming from Asia, from somewhere else with low, cheaper sensors. There will be also different kind of quality of of systems. Did you think with a product like yours, you can also increase the accuracy of maybe a low-level system to make it more accurate if you combine different scans together, or make an adjustment?
Yeah, I think so. Yes, absolutely. Because the thing
if
is,
I think on craftsmen don't want investing 100,000 euros in the best scanner, but they want to have also a good accuracy. So
yes,
it's your solution, maybe a solution that helps craftsmen following maybe a 15,000 euros device and get the accuracy out what they need for their projects.
Well, I think so. Well, of course, I'm a little bit biased, but from an academic perspective, it's always smarter to extract features and then match them, because a feature is more accurate than a single point.
Yeah, okay. That's what I mean.
Yeah,
like with this feature extraction, and then you take the noise out of the data. What I mean, if you have a noisy sensor and you make point to point, then you calculate it with the noise.
Yeah.
If you have before, like in patches registration, then you have a more accurate feature, because you have the middle, let us say the middle value, and then the final result should be better as the original single point accuracy.
Yeah, that's correct. So this is why we're also not too scared of stainless steel in plants, because it doesn't make a difference. Just think of a bed. So if you got a very hard bed, that's your level of noise. If you got a very cushioned bed, we don't care, because the plane actually will be somewhere in the middle.
Okay.
That's it. It's not too much of a difference.
Very good explanation to deep topic. I'm happy to see mobile stuff and tested this, because this coming more and more, but this have challenges, and I hope the SCANTRA is a good solution to fix this issue. So, and for international customer, how they can find you? I think it's your website are.
Yeah, one source is a homepage. We got international and national resellers such as you.
Like
so
you can also, for European customers, they can also contact us. But you have also resellers over the world, or?
Yeah, we got Aptella in Australia. We got Positix in France. We got Scanomatic in France, and we got Made Technics in Flanders in Belgium region.
Okay. Did you have somebody in the US?
I think that's it. No, we don't have.
So I think if you are somebody from the industry and looking for a great product to sell, I think speak to Daniel. So it would be good. So I think there is a big market also in the US for this, and also other regions. Hey, I'm here on the booth from CHCNAV, and I find some products long time interesting. It's a kind of underwater scanning, but I have a gentleman here. Maybe you introduce yourself and what you're doing.
Okay. Hello everyone, I'm Sean from the CHCNAV Marine Product Line. So we are from the Shanghai, and we are the manufacturer of the USV part. So today I'm very honored to have the Enrique here, and we together cooperate for the USV part, and we have different USVs like bathymetric USV and hydrographic USV, and also we have different sensors, single beam, multi-beam.
Let us go to the box.
Let's go. Okay.
I think we're starting with this. This is your entry market product, or
exactly.
Okay.
This is.
Let us say.
Okay. This is our entry-level model, like UpG3 Pro. So it's already integrated single beam for bathymetric surveys, and you can see it's very compact and convenient. It's only 1 meter length, and the whole material is carbon fiber materials. And we have the 4G connection and the Wi-Fi connection.
Okay, and you have for the operation, I know there's also a camera inside. You have like a controller, like from a DJI drone. So you can then operate it like with manual sticks, but then you can also give a pathway, and then you automatic drives then on an area. So,
we have this function.
So then let us go to the next boat.
Okay. So this is our mainstream model in Europe. This is UpG4, and with UpG4 we can carry the multi-beam sensors and single beam already integrated. But also for the hydrologic we can carry the ADCP. So you can measure the discharge.
Okay, the discharge. And here this is the IMU, or?
This is multi-beam deck unit.
Multi-beam deck unit.
Yeah.
Okay. And this is the single sensor.
Yes, this is our multi-beam sensors.
It's a multi-beam sensor.
Yeah.
Okay.
All this part we are the manufacturers, and it's our own developed.
Yeah. Okay. And this one is for, what is the difference? This is a super large boat.
So this one is our biggest model, UpG6. It can use in the near coast and also some offshores, because some big wind, big wave will influence the data qualities. So this one is much more bigger and more stable for the system.
Yeah, I think it's also have the side to make it more stable.
Yeah. These two floating boats, we can disassemble it and assemble it. When we do the transportation, we can disassemble it for more easier for transport.
But with the battery charge, how long you can drive on with this big one?
Also for this big one, we can use 3 batteries more than 3 hours one
3
time.
hours?
Yes,
Okay.
more than 3 hours.
Then after 3 hours, you're totally seasick.
Oh no, after 3 hours you can do the battery change.
Yeah, okay. I have another person here. Maybe you introduce you. What is your name and what you're doing at CHCNAV?
I'm Andre Gorb. I'm a segment director for mobile mapping solutions in EMEA region.
So, and then we can go direct to the product. So let us tell me what we see here.
So actually, this is our pioneering product. We released it on Intergeo 2022. It was a first scanner made totally by CHC Navigation. He has a classical profiler. We call it Alpha Uni 20. Uni means universal installation. So idea of this device is just one scanner you can put in multiple environment. As we can see here, classical vehicle-based system. It could be single head or dual head. Then you can easily dismount it and put it on the rotor drone, fixed wing drone, train, trolley, USV like our Apache series, so the big boats, and even with range of 1.5 kilometer, you can put it on the helicopter.
Okay.
So very, very flexible. And in continuation, we continue our development. We want to have one entire ecosystem. So as addition, because now you see we use our FLIR Ladybug 5 Plus camera or Ladybug 6, but in some, let's say, cost-challenging area, we want to provide a solution to our clients. And we release these days 2 panoramic camera from CHC. It's 48 megapixel camera and a 72 megapixel camera.
Okay.
They can work as addition
To
this one, yeah, but also you see they could work as a standalone system with the INS box. We include GNSS antenna, memory, and with the INS it will give you panoramic georeference pictures. Same installation concept, same telescopic extension, power supply, odometer. Also we have a backpack mounting, so it's very, very flexible.
Andre, very nice for a
pleasure.
quick introduction. So,
Thank you.
I hope we can show in the future some results, some pictures, some examples. So, yeah, we go forward.
For sure, for sure. Very welcome.
Yeah, we here on the booth of To Freedom is the name of your company. Maybe you told us where you are and what the company is doing.
Okay. To Freedom is a company from Spain, and we are a research and development company, and now is the first year that we are going to sell our own products. So we are here the first year that we are going to be in Intergeo selling our own products.
Yeah, and now you decided to bring an own product on the market. What we see here?
Yeah.
Are there maybe the background? I think you have a good background in photogrammetry, or
Yeah, I'm a doctor.
Yeah.
Doctor in photogrammetry from the
computer vision, also computer vision.
and computer vision also. Computer vision. My specialize is videogrammetry, we can say.
Okay.
How from videos we can obtain the best
3D content?
Exactly, 3D content, trajectories, bundle adjustments, and so on.
Okay, that's cool. So yeah, and then this is it's now one of your first developments under your own brand.
Yes.
So you have come from Spain, yeah?
Yeah,
So,
yeah.
but tell us something to this device.
Okay, this is a videogrammetric scanner. It has 2 cameras and 1 IMU. Okay, the small camera is to develop the visual slam, so we can move, and in real time we know the position of the system. The big camera is to record high resolution imagery with high quality, with a very nice lens, very big sensor, and then the global shutter sensor to don't deformate the image. Very nice, very important when you move. And then you also have an IMU to help all this procedure to create the bundle adjustment with accurate and don't lose the trajectory and so on.
Okay, cool. And I saw some results, looks very amazing. So I think behind maybe cut them later inside some of your results.
Yeah, okay.
I saw some of your results and looks really great for a camera device. And you get also like it's not like like only camera, also it's super accurate. Also with photogrammetry, you have the option to be super accurate with your data.
Yep.
But if you're using SLAM technology or visual SLAM, you get also the drift stuff inside.
Yeah.
This means you need something like this
Yeah,
to fix
yeah.
this. I think what I saw that you can get out with this device very good accuracy. So under 1 centimeter on small areas.
Yeah, it depends. Of course, photogrammetry itself is very accurate.
Yeah.
So if we choose the best images possible, even if we have a video, the accuracy will be also good. Of course, as all the SLAM systems, we can have the drift. And the formations, in the moment that we move, of course, we will accumulate the formations. But even with that, if we have a good practice, we look the closer, or we put targets, we can have a control of these deformations. So we have here examples of one, for example, one of the last one tunnel, a big construction company is developing with these systems. They have put a few targets, and every day they are scanning 150 meters with this one, and the accuracy is 7 millimeters. So it's quite
I think
unavailable.
to be honest, I think it will be not better with intersticle scanner. So 7 millimeters on 150 meters with different setups. You will be in a real 3D accuracy. You will be at least in the same accuracy level. Because a single scanner have not 1 millimeter like everybody say. 3D accuracy of single scanner is maybe 3 millimeters, 2.5, 3.
That's right.
Something, and if you have different setups, you are easily also at 7 over 150 meters.
Absolutely agree. Probably in one setup, the accuracy of one nice, good laser scanner is very good.
Especially if you take it now, and you have to take it now, like so 360 degrees. That will be better, but especially on a long track. So I think it will be super similar.
Yeah. So they spend less time in scanning. Because in 10 minutes they scan. They scan the
150 meters in 10 minutes. So you go like it was a.
It's walk and scan like that, right? So and they come back again for the other place.
Should I tell you a funny story? You know, any people know I have a long time history in Faro, and then in 2003 or 4, I speaking with one of the Faro chief developers, say how scanning should be, and it should be the best in the future. We have something like people going like with a video camera.
Okay.
And you're the first guy to bring it out after 20 years. So
Probably.
Very funny. So very good. So what is interesting, of course, if you use photogrammetry, this means the device have to be not so super expensive.
No.
So I think have a super affordable price for customers. Is only a part of a 3D scanner. And I think the modeling have to be done. What I heard is cloud-based modeling.
Yeah.
And if you're a big enterprise customer, have data security, they can have also a local installation.
This is like that. Also for security or police or so on, they can have a local process, yes. So this is the possibilities, local process, depend on the use. So
I think we will bring something more from that. I like it. So it's very interesting. I think for me actually this year most innovative product what I see. So besides now mobile scanning is now big. So but this one is very interesting.
It's different, no? It's different. So.
And it's maybe also I think you have a frame inside. Did you need calibration, or it is usually?
It has already a calibration. We calibrate in the manufacturer.
But then after that, this is stable. So if people are carefully working with that, because you don't have so many moving parts inside, that's also interesting.
No, exactly. The global shutter sensor, if the light is good, you don't have blur in your images.
Yeah, cool. And I think have many potential this technology.
We think so also.
Yeah.
We think so. We sometimes we are surprised of the use of this system. Even we have manufactured this one design. But sometimes the people is using with results that you are surprised. So let's see.
Very good. That's nice.
Thank you very much.
Let us look that we find some more interesting stuff here. I will go forward. Here we have the next generation of race cars. So it's a fully autonomous race car, and I think what they're showing here is that they're using an RTK services for the positioning of the car. So I think that's the story here. Hello, here we are at the XGRIDS booth together with Sunny. And Sunny, you like to presenting something to us, new stuff?
Absolutely. This is our very new scanner, the PortoCam. We actually just launched just last month, but you know, this is a new scanner or camera almost built specifically for Gaussian splats. So you can see we have the LiDAR on top, but at the same time we have 4 cameras, the two 360 cameras, but as well as the 2 front cameras. So what that gives you is that a very high fidelity of the Gaussian splat models, and actually a lot of details at the same time because it's taking all the photos, all of them as you're scanning. So yeah, we actually can do some very, very cool models.
Yeah, I saw that. We checked this out. The models are super cool. The Gaussians looking super great. And also the price tag is also good with super affordable price.
Absolutely.
So yeah, it's around euros, like 5,000 euros around.
Yep.
So it's very cool.
Yeah.
So, and then we have another product was launched here.
Yeah.
Is this one? It's a new mount for the LS2. And what I like, maybe you can show it. We can show it live here, or
I don't think we have.
It's working like electrical. So you have here some.
Yeah. You can see that it's already automatically starting the suction.
Suction electronic.
Yeah, of course this surface is not the best,
Yeah,
but
no.
then it also detects the pressure.
Yeah.
So therefore, it's once it's done, it's already fully mounted on a vehicle.
Yeah, and then you have a remote control by your
Yes.
mobile phone. Yeah,
Yes,
I like it.
to look at that.
It's also very smart, a cool thing, and how you built this. So looks very good. So I think it's best holder what I saw somebody create.
Yeah, it's very cool, and we're very excited to see the data sets that's being created with using these products.
Of course. Yeah, I think we have it.
Cool, perfect.
Hello, my name is Mohamed Guntaf. I am part of Sony Europe. I'm pre-sale engineer, and I'm doing all the technical support regarding all the cameras that I use for B2B application.
So, and now we have something new. The Sony is now also a producer of laser scanner. That's right?
Yeah, this is the ASDT1, which will be released next year, so 2026, beginning of next year. And this is a 3D sensor inside, LiDAR, and it's using DTOF, direct time of flight.
I think I saw there was the first announcement maybe last year or some.
Yeah, beginning of this year.
I can remember.
So this is a prototype, but as you can see here on the screen, it's already working. So what you will get, it's 24 by 24 cloud points, so 576 points, and the field of view is 37 degree horizontal and 30 degree vertical.
Okay.
And regarding measurement, indoor it can go up to 40 meters, and outdoor 20 meters.
And what is the application? What you think? Like, which kind of people should be use it?
So different applications. So here for Intergeo, we had a lot of interest regarding mapping for SLAM application. For instance, handheld.
Handheld scanner,
handheld scanner, because it's really compact, as you can see.
You can put it inside.
Yeah,
maybe
inside and lightweight.
Makes
Both.
sense. Yeah, okay.
Also on drone it can be used around the drone to make collision avoidance. So as you can see on the back, you have 2 USB ports. So it means that with the second one, you can daisy chain up to four.
Okay, you can collect it 4 together.
Yeah, 4 together.
Okay.
So it means you can use it for collision avoidance. Also, if you put it down the drone, you can use it for landing.
Okay.
To detect if the surface is flat.
Yeah, that makes sense.
Yeah. And also for inspection. If you want to be in front of the subject and to align with the subject, you can use it.
Yeah.
And then also on the still image coming from the RGB camera, you can scale it you can scale the image.
This is a system for integrators, so
Yeah, for instance.
okay.